I didn't actually really have any material, so.
What do you, are you still doing translations and rotations in class, or have you moved on to congruent triangles?
Triangles.
Right, good. I think they spend too much time with translations and rotations, is my honest opinion. So let's go to congruent triangles, chapter 4 in the book. How many classes have you had on congruent triangles yet? Did you just start, or have you had one or two, or?
Today was our first day working on it, so.
Okay. Now let's see, what can we do here? Let's talk about what makes a triangle congruent with another one.
All right.
Okay. If I have this right triangle, and this is 3, 4, 5, if I want to draw a congruent triangle with that, it has to have the same 3 sides.
Okay.
Okay? Doesn't have to be positioned the same way. In other words, I can draw it like that, and it's still congruent. And this perhaps is one of the differences between congruent and equal. These two triangles are congruent, but one might argue that they're not really equal, because one is a rotation of the other, right?
Yeah.
One of the advantages, that's why they do transformations and rotations before they do congruency. Just occurred to me. Is because you can kind of see that these can't be equal since one is a rotation of the other, but they are congruent. And congruent triangles have the same 3 angles and the same 3 sides. Always.
Okay.
So, there are a few things that make triangles congruent. One is side, side, side. They have the same 3 sides, they're congruent.
All right.
The other is side, angle, side. In other words, if I draw that, and that is 40 degrees, and that's 4, and that's 7. There's only 1/3 side I can put on that.
Yeah.
And that's connecting the 2 endpoints. So if I had another triangle that I knew was 7 and 40 and 4, even without knowing this 3rd side, I can assume that those 2 triangles are congruent. That's all I need is side, angle, side. You realize why it's side, angle, side. In other words, it's side, the angle between them, and the other side on the other side.
Okay.
Turns out that side, side, angle does not guarantee congruency. What would that look like? Side, side, angle. Well, what if we had the following picture? In other words, I know this angle here is 40 degrees, but I know this side here is 8, and that side's 10. Notice in this case, I have angle side side, or side side angle, if you want to look at it in either order. In other words, this scenario is side side angle. It's where you have 2 adjacent sides that you know, and then you know the angle of the opposite of one of the sides. In other words, this 40-degree angle is opposite side 8. Okay? Why does this not guarantee congruency? Well, I'm going to draw another triangle that has side 10, has side 40 degrees, and has side 8. In other words, this second triangle has 8, 10, 40 degrees. 8, 10, 40 degrees. But it's not congruent.
Okay.
In other words, I can take this side of 8 and I can just merely turn it to that to create this triangle over here. So side angle is not proof of congruency. So just kind of remember that. So far we only have these two. How about angle, angle? Or angle, angle, angle? In other words, that's 50, that's 60, that's 70. Is that enough to guarantee congruency?
I think so.
Well, I'm just going to draw a bigger triangle. It has the same 3 angles. Is this triangle congruent with that triangle?
No. They're similar, not
They're
congruent.
similar, but they're not congruent. You're going to start off with congruency and move on to similarity. And for similarity, you don't need angle, angle, angle. You just need 2 angles. In other words, if I know one triangle is 50 and the other is 70, and I know this triangle is 50 and the other is 70, that third angle has to be 60 in both cases. So when you do get to similarity and angle, angle, angle does work, it doesn't need all 3 angles, just 2 angles. In other words, angle, angle is proof of similarity. But angle, angle is not proof of congruency. It just says they're the same shape, not necessarily the same size. Notice that side, side, side does guarantee. In other words, I can't draw a similar triangle that has those same 3 sides unless it's congruent. Obviously this one, that size 5, is not the same as that side 5. So side, side, side does guarantee congruency and similarity, but we're focused just on congruency at the moment. And the one other case that guarantees congruency is if you have right triangles. With a right triangle, the only thing you need to be congruent is one angle and one side. In other words, if you tell me that angle is the same as that angle, well, the fact that this is a right angle guarantees that this angle over here is the same as this angle here. So now we know that all 3 sides or all 3 angles are the same. So the only thing we need at that point is if one side is the same. If that's 4 and that's 4, then I know those 2 triangles are congruent. And the minimum amount of information that I need is that. In other words, for a right triangle, I still need 3 pieces of information, but one of them is the right angle. Notice that this right triangle also is angle, side, angle. Well, there's another one. Here, let's talk about that one first before we talk about the right triangle. That also is a measure of congruency. And why? Well, if I know that angle, that side, and that angle are the same as another triangle that has that side the same. You know what these hash marks mean, don't you?
Yeah.
Okay. And this angle is the same as this angle, and this angle is the same as this angle. Well, there's only one place for these to connect, and there's no way to draw this multiple ways. It has to be drawn like that like that. They're congruent. So angle, side, angle is enough to prove congruency also. Angle, angle, side is also enough to prove congruency. No, they don't teach you that one so much. The reason is if you have the two angles are the same, then all three angles are the same. And if you have one side is the same, as long as it's the proper side, that's why they don't teach you this one. And let me give you an example. In fact, this might not even be a theorem. If I have those two triangles there, and this angle is the same as that angle, and this angle is the same as this angle, well, I know the third angle is the same, but saying a side is the same, what if I said this side was 4, and that's equal to that 4 right there? Well,
They're congruent.
Those two triangles are not congruent. For them to be congruent, they have to have all three sides the same. Notice this side that's 4 is not the same side as that. This side on the bigger triangle is the side between that angle and that angle. Whereas on this triangle, I made it 4 opposite the single hash mark angle. In other words, the side that's marked 4 on both the triangles is not the same side. This is the side of the, in other words, if this was 4, then they would be congruent. But if I just choose arbitrarily to make one of them 4 and not the proper side, then they're not congruent. So angle, angle, side is not proof of congruency, unless you insist that the side be this side over here. In other words, maybe it is if it, in other words, this is angle, angle, side, this is angle, angle, side. That would be proof of congruency.
Okay.
All right. You're going to learn all these again. I just thought I'd give you a heads up on them since you don't have any homework specifically to work on. Let's talk about triangles. What's an equilateral triangle?
All the angles are equal?
Yeah, no, that's equiangular.
Okay, so all the sides are equal then.
Well, both actually. But technically, the definition of equilateral triangle is all three sides are the same.
Okay.
Now, that means all three angles are the same also. And let me talk about that for a second. In any triangle, the longest side of the triangle has to be opposite the biggest angle. The shortest side of the triangle has to be opposite the smallest angle. So it would not make sense to say that's 10 and that's 11. Because I would have the 11 opposite the 50-degree angle, and my 10 is opposite the 70-degree angle. So that could never be. Okay? I could have this be
Yeah.
a 12, and this be 11, and this be 10. That works. In other words, my smallest side's opposite my smallest angle, and my biggest side's opposite my biggest angle. That's why the hypotenuse of a triangle is always the longest side of that triangle, because it's opposite the 90-degree angle. And the 90-degree angle is, by definition, the longest side of that triangle, or largest angle of that triangle. All right, so equilateral is also equiangular. They mean the same thing. It's just that the equilateral technically means three sides that are the same. What if I just have two sides that are the same? What's that called? Isosceles.
Okay. Isosceles.
That one's much more common. You're going to come up against isosceles triangles much more frequently than you come up against equilateral triangles. I mean, if you're talking, ACT test or anything like that, they give you lots and lots of questions regarding isosceles triangles, very few regarding equilateral. A scalene triangle is one that has three different sides, which means three different angles also.
Okay.
It basically means no congruent sides. And since the side to angle relationship has to be the same, if none of the sides are equal, none of the angles can be equal. This has to be one, this has to be a double one, this has to be a triple one.
Okay.
Okay. So all I'm doing is going over the first page in section 4.1 that you probably went over this today in class.
Yeah, some of the triangles we did.
Yeah, an acute triangle. Again, this is not one you get very much, but pretty easy to figure out.
All sides are less than 90 degrees.
All angles are less than 90 degrees.
Oh, yeah.
Okay. And then you have, if we're classifying by angles, then you have the equiangular triangle, which is all three angles are equal, and we know that's true with an equilateral triangle. So equilateral and equiangular triangles are the same thing.
Okay.
Equiangular is also an acute triangle because all three angles are 60 degrees. Right triangle, most common by a lot. Most all trig starts out analyzing right triangles. And the only thing you need for a right triangle is one and only one 90-degree angle. Notice you cannot have two. If I put two 90-degree angles into a triangle, well, I don't have any room for a third angle because the sum of the angles has to be 180. So if I have one 90-degree angle in a triangle, that's the most there can be. In other words, if this is 90, the biggest that could be would be 89 and 1. Because these two angles, the two that are not the right angle, have to be complementary.
All right.
Okay. And finally, I have an obtuse triangle. Merely means one of the angles has to be greater than 90. As long as we're talking about triangles, let me introduce you to a rule that you may not even get in this chapter, but it's good to remember. Let's go over it, because this is one you'll be asked upon to do in your standardization tests also. And it says the following. Any side of a triangle has to be less than the sum of the other two. That's all you have to remember, because the second half of this theorem is the opposite. It has to be, any side has to be less than the sum of the other two and greater than the difference of the other two.
Okay.
Which means, could I have a triangle whose dimensions are 2, 3, 5?
Yeah.
No. Remember, any side, that side right there, has to be less than the sum of the other two, and it's not. It's equal to it.
Okay.
Okay?
Yeah.
Now, 2 is also not greater than the difference of the other two. The difference between those two is 2. Well, 2 is not greater than 2. It's not greater than or equal. It's greater than. So,
All right.
let me give you some triangles, and you just tell me whether they're possible or not. Now, in order to tell me whether this is a possible triangle, you actually have to go through 6 calculations. In other words, you have to test all 3 sides to make sure that every side fits both of these things.
Okay.
So, does 7 work? We'll analyze it first. Is it less than the sum of the other two?
No.
Yeah, no, the sum of the other two is 18. 7.
Okay, yeah, sum is sufficient.
Yes, 7 is definitely less than the sum of the other two. Is it greater than the difference of the other two?
Yes.
Okay, so that side works. Let's check 8. Is that less than the sum of the other two?
Yes.
Greater than the difference?
Yes.
And finally, let's check 10. Is that less than the other two?
Yep.
Greater than the difference?
Yeah.
I can definitely draw this triangle. Could be like that. Notice why it has to be greater than the difference of the other two. Let's say I take that triangle that I asked you about, a 2, 3, 5, and I try to draw it.
Okay.
Okay? Well, there's my 5 side. Well, the shortest distance between 2 points is a straight line. So that's the shortest distance between those 2 points. If I try to make that 2 and that 3, then I'm saying that I can get between those 2 points by going 5 miles in a crooked manner. Can't do it. In other words, if I want to get from this point to this point, and I only want to travel 5 miles or 5 whatever, I got to go in a straight line, because the shortest distance between 2 points is a straight line, which means there's no way I can get there by going this crooked way. I can't go 2 units that way or 2 miles that way and 3 miles that way at an angle and get to that point. I'm going to come up short. So if I were to try to make this a triangle by drawing the other 2 sides, the 2 and the 3, well, the 2 gets to right there, the 3 gets to right there. That would be 2, that would be 3, but I wouldn't have a triangle. I'd have a straight line, or 2 lines on top of one another.
Okay.
So that's why, and this isn't a bad thing to remember, because in case you forget this rule, this is the best way to look at it. That 5 has to be less than the sum of A and plus B. Always. And so as long as you remember this model, you'll always remember the first half of this rule, and then you got it memorized, because the second half of the rule is just the reverse. Reverse that and turn sum into difference.
Okay.
Okay? So,
Yeah.
I'm just going to give you another few triangles here. Let's add a triangle.
So, which angle of it?
Don't need to know the angle. So all you need to do is know the rule. The rule says any side of a triangle has to be less than the sum of the other two and greater than the difference of the other two. So apply those rules. Might as well start on the left.
That's not a triangle because 2 is the same as the difference.
Correct. Triangle or not? Usually when you're doing your tests, if one fails, more than one is going to fail. In other words, you really don't have to test all three sides. Just start with the 4 and see if it passes both tests.
Well, the 4 and the 5 work, but the 10 doesn't.
Hold on. The 4 works for being less than the sum, but it doesn't work for being greater than the difference.
Oh, okay.
Right?
Yeah.
You see that?
Yeah.
Right. In other words, the 10 would have failed because the 10 is not less than the sum. But that usually means one of the other sides is going to fail also. Well, the 4 fails immediately. The 4 is less than the sum, but it's not greater than the difference.
Okay.
All right. That's probably a good place to stop.
Okay.
Okay. So you'll be on this congruency chapter for a while, I can assume?
Yeah.
Okay.
Probably for at least a week. So.
Yeah. Okay. Cool. I will talk to you at 4:30 next Tuesday.
All right. Thank you, David.
You're welcome. Have a good weekend, Mark. Bye-bye.
You too.